One is by alkaline hydrolysis of gem dihalides. Now the question now is, what is a gem dihalide? A gem dihalide is an halide that have two halogen group on one carbon. For instance, if you have something like the CH3, CH, and then you have Cl, Cl, you discover that these two chlorine group here are attached to one carbon. So this is a gem dihalide. You can see this chlorine and this chlorine are attached to this carbon. So this is a gem dihalide. What is the name of this compound? 1,1-dichloroethane. Now you must be careful, because in the exam they may not likely give you the name of the structure of the compound. They may give you the name and then ask you to write the reaction. Now when 1,12-dichloromethane reacts with sodium hydroxide in water, what will be the product? It's called hydrolysis, alkaline hydrolysis. We have acid hydrolysis and we have alkaline hydrolysis. So for the alkaline hydrolysis, of course, you have the alkaline hydrolysis. You need what? Water. What will happen is that this group here will be substituted with OH. These two group here, they will be substituted with OHs. So here will be CH3, CH, here will be OH, here will be OH. Now this compound also is unstable. So what will happen is that water will be removed from here by dehydration. Now if water is removed from here, this is going to give us CH3, C double bond O, hydrogen, which is ethanol. Now how do you remove water from here? Remove OH from here, remove hydrogen from here, a double bond will be formed here. Is that okay? So that will give us the ethanol. So that is that. Now for ketones, they are obtained by alkaline hydrolysis of non-terminal gem dihalide. This one you see here is a terminal gem dihalide. Terminal. Now why do you call it terminal? Because these two chlorine group are attached to the last carbon here. Is that okay? Because these two chlorine group are attached to this last carbon here. That is why you call it terminal. So for terminal gem dihalide, they are going to give aldehyde. Why for non-terminal, they are going to give us ketone. So for instance, if we have something like CH3, C double bond O, sorry, here will be Cl, Cl, CH3. This is a non-terminal gem dihalide. Alkaline hydrolysis requires sodium hydroxide and water. This group here will be substituted by OH. More like, yes, substituted by OH. So here will be CH3, here will be C, here will be OH, here will be CH3, here will be OH. Now what do you think will be formed here? Remove water by removing this OH under and one hydrogen here. A double bond will be formed here. So what do you think we are going to get? So this one now is minus water. Remove water, and then this is going to give us CH3, C double bond O, CH3, which is a ketone. What ketone is this? Acetone. So you see that these things are very, very easy. Now the next one quickly is by pyrolysis of calcium salt of the acid. Now by pyrolysis, what do we mean? Breakdown. Are you getting it? Heating to a very high temperature until it breaks down. Pyrolysis of calcium salt of carboxylic acid. Now calcium has two ions. Carboxylic acids have just one ion, which is something like the CH3, COO negative. So in order to cancel these two ions, it means we'll be needing two molecules of, two negative like this, or two minus, we cancel these two ions. But the carboxylic acid ion or the carboxylate ion has just one negative. So we need two molecules of this. Alright? So this is the calcium salt of the carboxylic acid in question. Now, in this case, if you heat this calcium salt of carboxylic acid, when we talk about pyrolysis, it's more like cracking to a very high temperature. All right, pyrolysis, heating to a very high temperature to break a large molecule into a smaller one. With a temperature of 400 degrees Celsius, what will happen is that this group here, look at it, this group here, just see what I'm going to do. We combine with here and then with one oxygen from here. Are you getting it? So see how I cycled it. This COO here, Ca, and then one oxygen from here. Are you getting it? So you are now having two negative as part of this group here. So we have two negative, two positive. They will cancel and give us a neutral molecule. So that at the end of the day, what do you think will be left? The next thing, you add them together. So from on top here, you have CH3, C double bond O left. That is still CO. This CH3CO that you have here, C double bond O. Then what do you have left from the under? You have CH3 plus, now when this combine, it's going to give us Ca, which is this Ca. Then we'll have C, which is this C. How many O do we have? 1, 2, 3, which is CO3. All right. So this gives us propanone and calcium carbonate. What did we start with? Calcium acetate. We started with calcium acetate. Is that okay? Now, the calcium acetate itself is produced or is formed by reacting calcium hydroxide or calcium oxide with carboxylic acid. So when you react calcium hydroxide with the corresponding carboxylic acid, which in this case is going to form this one you have here, all right, which is CH3 COO negative, but you'll be needing 2 molecules of this, 2 and then Ca. Is that okay? So that is what this is all about, by pyrolysis of calcium salt of the acid. So you should look at it very well. Now the next one is by reduction of acyl chloride. Now what are acyl chloride? Acyl chloride, something like this. When you have this acetyl group here attached to a chlorine, you call it acyl chloride. So we say aldehyde may be prepared by hydrogenation of acid chloride. Some people call them acid chloride, right? In the presence of palladium supported over poisoned barium sulfate. Now the reason why you are actually poisoning the barium sulfate is so that it will not convert the aldehyde form to carboxylic acid. Like we said, that aldehyde form has the tendency of being converted to carboxylic acid. Are you getting it? This Roseman reduction is the process when palladium and barium sulfate is poisoned with sulfur to deactivate further reduction to alcohol. Okay, this one is actually reduction, not oxidation now. It's more like a reduction reaction, not oxidation. So this one is, if you have something like this, let me give you an example. Here is CH3, C double bond O, Cl plus H2, and then you have PD, barium sulfate, poisoned. Now, it's going to reduce. When you say reduce, that means remove. Reduction is also removal of what? Electronegative atom. That is also reduction. If you remove an electronegative atom, you've reduced it. So we are reducing it by removal of this chlorine we have here. So when we remove this, what is that going to give to us? It will give us CH3C double bond O CH3 plus what? HCl. This here is okay, not CH3 here. Here is hydrogen because you are substituting this hydrogen with this chlorine. It's reduction reaction. So this will give us ethanol, or you can also call it acetaldehyde. Are you getting it now? So that is that. Now the next one is the Ozo process. Now for the Ozo process, it's an industrial method for production of alkanal. It is what? An industrial process for production of alkanal. It involves the treatment of alkene with carbon dioxide and hydrogen in the presence of carbonyl catalyst. High temperature and pressure is used. Ketones cannot be prepared by this process. Now the Ozo process, ketones cannot be prepared by the Ozo process. It's a very good objective question. So the following cannot be prepared by the, which of the following can be prepared by the Ozo process? Know that aldehyde can be prepared by the Ozo process, but ketones cannot be prepared by the Ozo process. So we have R, yes, CH2 double bond CH double bond CH2 plus CO plus H2, and then you have CO, yes, CO4. This is the cobalt carbonyl catalyst that we are talking about. Now, what do you think will actually be formed here? Listen, it's a very simple reaction. This carbonyl group will be attached here. Are you getting it? To this one, and then this double bond here will break. One hydrogen will be attached here. Are you getting it? Then one of the hydrogen will be attached to this group here, so that at the end of the day you are going to get something like this. See it? R, C, H, than one more hydrogen. From this hydrogen here, one will be attached to this carbon. So you have hydrogen attached here. Then you have this CH2. Then what will be attached to this CH2 is the CO. So we have C double bond O. Are you getting it? And then finally, here, hydrogen will be attached. So this is an industrial method for preparation of what? Aldehyde, the Ozo process, requiring carbon 2-oxide or carbon monoxide and what? Hydrogen gas. Now you give an anti-Markovnikov product, and ketones can also be prepared by this process. Now the last one we have here is the Waka process. Now this one, they are less common processes for of actually making aldehyde and ketone, but you also need to learn it for the sake of exam. Industrial method, Waka process. Both aldehyde and ketone can be prepared by this method. The Waka process, aldehyde and ketone can be prepared. Ozo process, only aldehyde can be prepared, ketones cannot be prepared. Now both aldehyde and ketones can be prepared by this method. It involves the treatment of an alkene with an acidified aqueous solution of palladium chloride and cupric chloride. So we have an alkene, all right, which is CH2 double bond CH2 plus palladium chloride plus H2O, water, and then we have the cupric chloride